Okay, hi everyone, let's get started. I've got quite a lot to talk about today. So I'm going to talk to you about immutable infrastructure, and my name is Justin Cormack. I come from this place, Cambridge, which is very close to here. It's a little tech village up the road from London. I work in security at Docker, but I'm an infrastructure person by kind of training, and I kind of really love working on infrastructure and things like that. So that's what I'm mostly going to talk about today. And we're going to have a bit of history in here as well, because I like history of computing. I think, although computing is a very new subject, our history is really quite interesting. So I'm going to talk about design of Linux systems and how we got where we are and why we kind of got stuck where we are and what's changed and what hasn't changed. This is a picture of the founder of Sun Microsystems with the first kind of recognizably modern computer that you'd kind of perhaps, if you were sat in front of it, you'd probably still be able to use it pretty much. It's graphical user interface and the Unix command line, and really not not too far away from the computers we have today. There was a great idea back in the late 90s, the 3M computer, a megabyte of memory, a megapixel display, and a megaflop of compute for under a megapenny, which is $10,000. And we still have that. We've got a lot more compute. The displays are a little bit better, but not actually that much, and we've got a lot more memory. We haven't multiplied all those things by 1,000 yet. The display is kind of the worst one, I guess. And this was this period sort of from the late 60s, 70s into the 90s in particular was where our kind of view of what systems that we use today were kind of formed. They're kind of bigger and they've got more packages. I mean, package management was the first thing that really made Linux and Unix before that actually usable. And it was the first thing that I remember when I first used a Unix workstation, a Linux machine. It was like, wow, this package thing is really cool. You can just install anything you want, just apt or RPM or whatever it was back in the day when you first started. And so package management was really really important thing from the point of view of actually making it better than things like Windows at the time, and things like that didn't have packages and everything was kind of complicated. And package management then led to configuration management. Pretty much the same date as package management. CF Engine was 1993, was designed for running cron jobs across a bunch of workstations without having to configure them all by hand. And Puppet, and so on, came around in the early 2000s out of that. And so, again, some of the ideas were older from the 50s, but this was something that came really after packages, because you could use configuration management to manage the set of packages across multiple machines rather than having to do it by hand. It really started as replicating these manual use cases, replicating, editing that config file and installing that package yourself. And it moved towards this sort of gradual model of consistent convergence to define states. But it's kind of, in some ways it's gone back. It still feels much more, more like SSHing in and making changes, but scaled up. And the whole model around package management still feels very much like this kind of Unix workstation model and looking after, pet machines to some extent. Pets and cattle, that was another bit of history. There was a talk from 2013 from CERN, still giving, as we have talks from them today as well. But this was the first talk to really give this idea of pets and cattle a kind of name. So pets were the machines that you lovingly hand cared for and you nursed back to health and had config management. But cattle were these identical machines that you started to scale out, and this was the sort of came to this idea of cloud native that we have now, of rolling things out at scale, having machines in bulk, scale out services, and those kind of ideas that we're starting to take for granted now. But this was a really 2013 was when this kind of started to become talked about and get a sort of name. The other thing that was really important was continuous delivery. This book, written in 2010, is still just as kind of readable as it was then, and really important and influential, and it's still kind of the standard. For some reason, it was only after I actually added this slide that I realized it was a picture of the Forth Bridge, and painting the Forth Bridge was the metaphor on the front. I don't know how I missed that when I read the book all those years ago. So continuous delivery is ability to get changes into production, and this is, again, one of these really, really important ideas, and people are now starting to become fixated on ability to get change into production, and safely, quickly, being able to fix things when they go wrong, and being able to deliver software more often. And this has been a really, really influential idea. And of course, this came along with computers on demand. Amazon EC2, 2006, so kind of not that long ago in sort of historical terms, but that was the idea of suddenly, instead of provisioning servers by hand, and again, the sort of manual processes, we would of plugging them into a rack and installing things by hand. You could have an API, and you could start to install your software with an API, and you could move more towards this cattle idea. And you didn't, rack things out manually and so on. And obviously that's, where the OpenStack model came out of. And by 2013 or so, when that CERN presentation was, this was becoming really, really quite important. So the thing I want to talk about today in particular is this idea of immutability. So back in 2011, Netflix wrote this really great blog post called Building with Legos, and came up and said, in the cloud, we know exactly what a server to be, and if we want to change that, we terminate it and launch a new server with a new AMI. And this was, quite a back in 2011 was quite a new idea, and people kind of interested in this. And there was another. This was kind of reacting against the whole kind of manual sysadmin model, where things would configuration drift would happen. Even if you had some config management, you never knew that some other things might be changed, and maybe not everything on the box was config management. When I was a sysadmin back in the bad old days, you always dreaded rebooting your servers because they wouldn't necessarily come back up again, because you never knew which bits of it had been actually done and tested properly and which bits hadn't. And this whole immutability idea from Netflix was about how to really change this paradigm and just say, we don't change things, we just build it, test it, put it into production, and then redeploy something. And if we want to do updates, sort of mutable updates on a server are really complicated in some ways. You have to know a lot about how to update software. You need to know what you need to restart. If you're updating a shared library, you need to restart all the processes that are using that shared library. How do you find out what they are? If it's a kernel update, you still have to reboot the machine, unless you're doing live kernel patching. If you update a config file, maybe it supports hot reload, or maybe it doesn't. You have to know information about the service. It's very complicated and non-standard, and updates generally involve some service downtime and some domain-specific knowledge, which is kind of one of the reasons why this sort of immutable paradigm helps. So there was, the idea that with a mutable server, you take services down and redeploy them locally, and you try and minimize the downtime on there. But the whole immutable idea is you throw away bring up another machine and then throw away the old one when it's come up, reprovisioning and that kind of model. So, components go out of service, but components each are individually disposable, not really immutable per se. And you're really interested in the system as a whole and not the individual machine. and you have some sort of orchestration layer that, in a simple sort of sense, that manages this. And then you can kind of think about this as kind of config management of whole systems and not caring so much about the individual machine components. We really want to, think about clusters and applications and, data centers and large-scale programming, not small-scale programming. And large-scale cluster management is already a really difficult problem. You've got all sorts of things to manage about scaling and consistency and replication and dealing with failures of different sorts and pieces. So having lots of mutability on the individual systems so that you don't understand those either is kind of a complicated thing. So, it's 2019. Why did these ideas from Netflix never really take off? Why did we get into this sort of state where we still tend to do things with config management and updating servers and individually and so on? We could have had this kind of this model of disposable machines and deployment updates and so on, and yet we're still in a kind of land where we're updating packages as if it's a kind of workstation. Well, kind of, number one, we kind of did. We got containers, and containers were launched in 2013, so very much the same time as the pets and cattle discussion was going on. And when Docker launched containers, they somehow managed to persuade people that you couldn't update the contents of a container dynamically, even though that's not strictly true at all. You perfectly well can apply config management to containers if you really, really want to. But we got to this point where there was a sort of a new set of tooling, and somehow when you introduce a totally new set of tooling, a new paradigm, it's actually easier to change the way people do things than it is to try and make them change the way they do things with their existing tooling and infrastructure. So config management in containers, although it is entirely possible, never took off. Everyone builds containers from scratch, deploys them, throws them away, deploys new containers. And orchestration for containers became really important really early. I mean, Kubernetes was launched in 2014 based on Google's internal tooling for containers. But, that was pretty much almost as soon as containers were taking off, there was orchestration and managing clusters of containers started to become an important thing. And I think this sort of cultural change of new tooling just made this so much easier. People were kind of ready for the idea of immutability, but they weren't ready for the idea of immutability with the things they already had, but they were ready for it with new things. And they kind of, people understood the benefit of basically doing this immutable thing, a single binary artifact, build it, test it, make sure it's all working, deploy it, repeat that update, continuous delivery, and there was became a huge community of work around containers for doing this. Orchestration just becomes standard, and we're getting towards this kind of model that we wanted. And during that kind of thing, package management was kind of fragmenting. Language package managers become really important, and the kind of original kind of everything's in your Linux distro world had gone away. But I think that a lot of sysadmins at the time complained a lot that Docker didn't really do package management properly, and people were installing any old rubbish in containers, and that was kind of true, but actually it was more driven, I think, the other way around, that a lot of the early adopters of Docker were people who package management was not working well for them. They were users of languages like Ruby and Python that had built up their own ecosystems for how to manage applications and application dependencies, and these people were in the kind of newer world of GitHub, where there was a huge amount of software, far more than a Linux distro could really manage anymore, and Git was becoming the distribution model rather than operating system packages, and the whole thing that we'd seen from before was starting to fragment again, and you're going back to the previous world before package management, where you had to kind of configure and install software more yourself, which was kind of But new tooling was coming along to kind of help you with that. But so we got that all in containers, but we didn't really get it anywhere else, like in VMs. It kind of did exist, it seemed. I mean, I was talking to some people from VMware that they built all this stuff in VMware, for example. And they built a whole thing for building small, lightweight, immutable VMs and deploying them and having a central hub for them and things like that. But these things, VMware never shipped anything, and various other things kind of happened, but never really took off. I was a sysadmin, as I said before, and one of the things I did at Docker was design a system that was built around this kind of model. I'm just going to talk a bit about that to give you an idea about what we, where we didn't go during those years and what it looks like. This was a project that started in 2015 when we were building Docker for Mac. We needed an embedded Linux system inside it, and the first commit, which I wrote, which was just the first commit, is just the description of what we're going to build. It says, don't require update, treat as immutable. We open sourced 2 years ago. I keep copying and pasting that slide and never updating it. LinuxKit is a config management tool in the sense, rather than a Linux distro, in that it's designed as a way of building Linux systems and immutable Linux systems for deployment. So it's a kit of pieces and components which are specified as containers that builds a whole bootable system image that you can run on a VM or bare metal or wherever you like. Small and fast in a way that and easy to kind of use in the sort of sense that container tooling is. And its kind of idea of packages are containers, so kind of chunks of functionality that do one thing. It's kind of built with exactly the same structure as a Kubernetes pod. It basically, when you boot up your machine, apart from just running the initial initialization, it runs a strictly sequential series of containers to start up and configure the system, and then it runs a bunch of services in parallel under containerd. So you can actually, if you've got something there's someone actually even wrote a tool that converts a Kubernetes pod into a bootable LinuxKit VM. They're specifically designed to be the same mental model and also actual physical model. There's a YAML file for config because everyone loves YAML in infrastructure. And you can see that basically, this is a very simple example. It starts up, runs DHCP to configure the Ethernet, and then it's running a Redis service and a Getty for login. It builds an immutable file system of any kind you like, an ISO or an RAMFS, squash of any, or ext4 or whatever you like. But at the runtime, it's all an immutable system. If you want to run mutable services on top, you can run Docker or Kubernetes on top. And so there's no install, update, reboot, and so on. It comes with lots of tooling. So lots of tooling, so you can build ISOs, AMIs, GCP images, anything you like. And it has a simple kind of workflow that runs on anything from AWS, OpenStack, or locally on a VM. So you just do build, push, and run like a container, but you're doing it in a VM. And I'll show you a quick demo. You just do LinuxKit build. Oops, I can't type. And it'll just build this thing, all the containers on it, run and build containers, and this is a service that's running Nginx, and then it'll create an image, create the file system, bootloader, and everything set up, And I can run this locally with QEMU, and it will boot Linux. Comes up, and I can check that Nginx is running from my console. It says the default Nginx. So I've basically built an immutable system that just runs Nginx, just like that, in a couple of minutes, which is really a very different model from the kind of I mean, it very much is like the container model, but it's running, effectively a part of. We've got lots of people that seem to be using it in production. These are ones I've kind of inferred. People don't generally tell us who's using it, but these are people I know who I think are using it. I really want to talk about why we didn't get kind of convergence between the model we use for VMs back in the day and for containers. The people who, containers really got the mind share around immutability, and this, it's only really recently that we've really started to get more of a convergence here. Immutable lightweight VMs are really kind of useful things, and I think that we can actually, we've actually got to the point where we can actually shift back into a sort of more convergent model where between containers and VMs and what's going on there. I think that having a model where you can build and ship VMs really fast and easily, like the kind of design we did for LinuxKit, is really quite useful. And I think more and more projects are starting to experiment with ideas around this. We've seen this. We've seen quite a lot of people building, especially projects around running Kubernetes like this and other things like that. But I think that having this kind of model for infrastructure is really kind of useful, and just that kind of historical divergence where containers went that way and everyone else didn't doesn't have to stay that way. And I think we can definitely reconverge towards that. There's a whole movement in the container space, particularly towards lightweight VMs like Firecracker from AWS and the whole Rust VMM project, which is kind of spun out of that, which is about building very fast lightweight VMs that you can run containers in. So from the container infrastructure point of view, we're getting to this point where lots of people are interested in running containers each in a VM for isolation purposes. And then we're seeing kind of the other way around. We're seeing container-like tooling like LinuxKit, which came out of how we like to work with containers and feeding that back into VMs, building stuff for automation and not for the human login case and so on, not building things in the sort of model of the Unix workstation, but in terms of actually, for large-scale automation, for continuous delivery. There was a quote from Adam, Adam Jacob, who created Chef, who times to do some crazy bullshit with operating systems. I think it's very much true that, that there's now a really interesting opportunity to experiment with these things, and I think that we're getting to the point where there's a lot of overlap between. There's a lot more overlap between the kind of container communities and the sort of people doing things with VMs and infrastructure, and there's a lot that we can cross over between these spaces and learn from them. And I think that it's a really interesting time for experimenting in new ways of running infrastructure and experimenting with really how to change. How to change the way people have been doing things, because we all know that we want to scale out and make our infrastructure easy to use, elastic and scalable, and there's lots of different lessons from these different communities that we can learn from each other, and I think that this is a really exciting time from that point of view, and I think we should definitely experiment with more stuff along these lines and new ways of doing things. So thanks very much. got a couple of minutes for questions. So, I think
so the one thing that I've always been interested in, having been around building Linuxes for quite a long time, the whole immutability thing. That back in the late 90s and early 2000s, we were doing that in the embedded space with tooling like Buildroot, like OpenInfra Days.
Yeah.
And I think it's kind of interesting that we kind of never learned that. That was such a niche thing that those lessons of how to build those really small, immutable Linuxes didn't really cross over into the mainstream. I think we've almost rediscovered it now.
Yeah, no, definitely. And I think there's a big crossover with things people are doing with edge computing as well, where a lot more of those people are coming into the community. I mean, I kind of worked in that space a little bit back in the day, and now I'm doing a bunch of stuff with edge now, and there's a real kind of crossover again. I mean, I have to say, a lot of that tooling was horrible to use. Yeah. I mean, that was, yeah. And I think that, but the ideas and yes, no, completely, yeah, yeah.
LinuxKit from a usability and end user perspective, it just didn't work as well.
Yeah, no, completely, no, and I think that now the edge is kind of joining this. The container and VM community now, and there's definitely a lot going on there. And a lot of crossover and yep.
I guess I worked in a similar space and I bought those tools in the early 2000s. I know it's to talk about configuration management, but on the kernel side, I think your Docker image contains a kernel that actually is quite big and has a bunch of hardware support. Is there any move to getting more minimal kernel? If I know I'm going to run on AWS EC2, I need a very, very minimal set of drivers. If I know I'm not going to be hitting BPF or anything, there's a whole load of dangerous features I can turn off. Is there any?
Yeah, it's kind of tedious.
I've been there, maybe.
Yeah, I mean, I don't know anyone. I think we need some better tooling for doing that. I think it would definitely be helpful. There's a lot of interest in it, but it's hard to maintain. We spent about a bunch of time with LinuxKit trying to work out how to do that in a maintainable way, and it's difficult because every kernel version, the config options change, and it's easy to get stuck in a difficult to maintain situation. We have a sort of compromise kernel with LinuxKit where it's most things you need, but modern drivers and VM support and hardware support for sort of 10 gig Ethernet and above, for example, which rules out a lot of the legacy. And we don't have
turned off Dallas 1 layer.
Yeah, and all that stuff, but we don't. But it's definitely not minimal. So yeah, there's definitely work that could be done there.
Can that be improved with better tooling, with integration with compilers and things? So like the microkernel model, where you only compile your libraries, only include the libraries needed, or
Yeah, the problem about Linux is it's hard to do that because it's hard to go between what you're using and what you actually need, and because it's the layers are not as it's harder to, the coupling's really hard to determine from looking at the program. Although I think that it's not impossible. I think, and there could be a lot more tooling to do that.
do we need a new OS architecture then? Like, I don't know, some of the things Google are doing.
I'm a big fan of that stuff. I think we're out of time.